Yeah.
Yep.
We're just going.
Hi. Hello, everyone. If someone doesn't know me, I'm Alex Strube from Jülich Supercomputing Center, and I'm here to talk about Blablador for a bit. Blablador is our experimental large language model server that I created for us to have it in Jülich. So if you want to have a look at the slides yourself, or copy them, you can just scan it. I see that there is one or two. Oh, right. Okay, then go to this link. This one will work. This is actually the Blablador itself. I just renamed the other one for a simpler URL, and
It was double H in the beginning of it.
Okay, so Blablador looks like this if you're using the web interface in not dark mode. And what is it? Well, this is how you pronounce it. The idea was that when we created it, a lot of people at the beginning of this story with large language models, people were freaking out with hallucinations. And my boss was really scared that if you put the server like this and people would start using it and the thing would hallucinate and create an incorrect answer, people would come back to us and say, well, I don't know, whatever. Yeah. And so today people are much more used to that and no one cares when those things give a wrong answer. But yeah, by the time, so we created with a kind of a funny name, saying that it does blah, 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 that it bullshits because, well, it kind of removes the pressure on us to have something that only produces correct answer, which is absolutely impossible. Yeah. So this is a stage for us to deploy large language models. Jülich is a huge supercomputing center, and we have a lot of people running things on our couple thousand GPUs there and training large language models. We have two concurrent projects right now. One for German large language model, which aims to be a bit more correct than the other ones. And another one that is supposed to be more like European thing. So when people came with those things, the idea was, and okay, so usually I keep changing the models that I have running there. If you open the previous link, you see that there are a number of different models there. Some of them are good, some of them are terrible. I just keep changing them. Usually I keep a small model. Right now I'm running something called Mistral from a French company. And one of the ones that is on top of the Hugging Face ranking. This is just to have some good models. What is Blablador in itself? Blablador is a web server with an API server and code for training. Yeah, so you can train large language models on it. So this was a guy that knows a bit more than I do about AI. And he was basically complaining that most of what you spend time on is managing versions of softwares. Yeah, and yeah, so this here, like when he talks about keeping multiple versions of Python in one application, I was like, well, I felt like he was talking to me. And so anyway, so why did I do this thing? First, because AI is becoming infrastructure. Yeah, it's coming to your phone, as large language models will probably be very soon on your phone. And infrastructure historically has been open source. Yeah, web servers, file servers, whatever. It's always an open source thing. So we created an open source a server for deploying AI large language models. And another thing that I realized that a lot of people who do research on AI, what they do is they train their things. They have a file with their weights. They do some evaluation, and that's it. Yeah, it's like at most they publish a paper, and those files lying around somewhere, no one is using it. And I didn't want that to happen. So what I did was to create a place where my colleagues can actually deploy models. Another thing is that we didn't have any experience when I started with this, with dealing with large language models at all. So, well, you start learning by doing, yeah? From the part of tools, this is very very dynamic field. Every week there's something new going on. Every day there's something going on. So I wanted us to have local experience on things like things from data loading, because a large language model can take like more than half an hour just to load in a GPU in some nodes with GPUs. Quantization to reduce the size of those models for inference on smaller devices. Distribution, because we have large machines and we have very large models that don't fit in a GPU, they don't fit in 8 GPUs, they don't fit in one node. So this is something that we need to learn how to do. Fine tuning large language models for specific tasks. A lot of people ask this. It's like, administration says, well, I have a lot of documents. Can I talk to my documents? I don't want to read all those documents. Or scientists, yeah, or like there was a guy on climate research. He said, look, I have 100 years of measurements and experiments. Can I ask something about this petabytes of data? Well, right now, no, but the idea is that we want to learn how to do those things. Inference speed, yeah, so this is another thing that has been changing a lot since I started up to now. I think I got like 20 times improvement in less than a year. It's crazy. Deployment, of course. And so those are actually the 3 projects that we have in Jülich that are producing large language models, and they would need somewhere to run. So this place where it's going to run is Blablador. So yeah, so the idea was that I wanted to be ready when they come with this thing and say, look, I have this thing where I put it to run. And the other thing, I did it because I could. Yeah. So okay, so a little facts here, just nothing much. We don't have any of our models yet deployed. Our nerds are like, oh, it's not good yet. It's not good yet. So I am running with this open source large language models for now. Models, they take up to 8 GPUs. For example, Llama 2 was one of them that I had running for a while. This is just, yeah. So those are the kind of deployment libraries that I have been using. Now I'm using a model called Mixtral as one of the large ones that I have running there. It's another one that takes me 8 GPUs, and they have to be loaded every time. Like I cannot just load on demand. This takes like 40 minutes to load those weights on the GPU. So I need those 8 GPUs all the time for this thing alone. Yeah, so this is something that people have to have very much into account when they want to deploy this kind of stuff. Yeah, it's not a cheap hardware. Yeah, and if you have it just for this thing all the time, well, it better be used, yeah. Another thing that I did that was very interesting for Jülich was that I don't collect the data of the conversations. First, because half of the conversations are useless, and second, because it's much less trouble for me. Germans are very paranoid about privacy, and having this was a huge advantage for me to sell this as a product in Germany, that I just don't keep data, yeah. And so you can use it, and you can keep the data goes nowhere. Yeah, the log files are usually kept for 1 day, or they go straight to DevNo. I could, yeah, but there is really no needs for that. For example, I made a code for running comparing models A and B, so you could check which one is better and this kind of stuff. But in the end, the GDPR and the privacy rules overtook it, and it's much less trouble to me to not keep anything. So this is a service that I'm offering for people. Right now, just from Jülich, they can actually deploy their models. So for example, if you have a large language model and you want to put it somewhere for people to actually use it, give it to me. Yeah, I'm also making it's possible to actually take your own server and point to Blablador. So it shows as on my web interface. So you don't need to worry about, I don't know, authentication, users, firewall, whatever. Yeah. So this is one of the things that I do as a service there. Yeah. So, and researchers that don't want to care about that. Yeah. If the person is doing the large language model, they want to know how good it is, some metrics, and people to test it and use it. Yeah. So all this kind of stuff I took care of. So yeah, so if you want to have a model deployed and you didn't, talk to me. In one of the talks that I give similar to this one, there was a guy who did a model on cosmology. He took an open source model and fine-tuned with all the cosmology data that he had. And now he can actually ask useful questions on cosmology. And this model is running on Blablador right now. If you open it, it's there. I can check here. So here are the models that I'm running right now. And then this Cosmos Age was one of those models that a person trained and gave it to me. I have it running for free for him. It's very nice that I have a scientific model running here, and it's a nice use case. What is it? Yeah, so Blablador itself, it's a Python code. Yeah, it's a normal thing. It's a model view controller thing for the ones who are into this kind of stuff. And this was made together with me and a company called EUM'24 from California. They are famous for releasing a model called Vicuña. Vicuña is one of those open source models. And they created one part of the structure to train Vicuña itself, and they put it open source. And now we have it together. We shared the code for Blablador and what they call fast chat. It's a Python app. Yeah, it runs on bare metal with virtual environments because, well, I will talk a bit more about that, but each model basically needs its own virtual environment because the tool demands are absolutely crazy on this thing. Yeah, the libraries conflict with each other. It's crazy. The versions of the libraries change every day. You cannot even count with tagged versions. You have to download things from main repos on GitHub and things like this. I put an authentication in front of Blablador with Helmholtz AI, first because I work for Helmholtz, and second because I don't need to do anything. I just need to create a configuration file, and it keeps. And this was interesting because I keep the bots out. If I leave this thing open, it's in seconds. I have people trying to do weird stuff with it. And also there is an API endpoint. Also, I created with Helmholtz Codebase, which is a GitLab server from Helmholtz AI. That's it, from Helmholtz Association, which is a research association in Germany. The API itself is absolutely compatible with the OpenAI, so the ChatGPT one. So you can do a pip install OpenAI, and it will just change a couple environment variables and point to my server, and you have a privacy respecting ChatGPT thing. Like, so for example, there is one example that I can show here. There is a plugin for VS Code called Continue, which is basically like GitHub Copilot, if you know this one. But it points to an open source server, so you can use it with Blablador to have a code assistant, for example. Yeah, there's a lot of people using for different things, but yeah, so that's the idea. And having it compatible with OpenAI, with ChatGPT, just makes it very easy for people just to port things here and try it out and say, okay, turns out that your model it's worse or better than ChatGPT 4 or whatever you're running, but it's free. Yeah, so the API is open for anyone to use. You just need to take a token from GitLab. This was just a a slide that my boss always asked me to tell, that we have all the supercomputers in Jülich, which are amazing. Well, no, it's not this. Yeah. It looks very nice like this, but no. It's this. So yeah, and the machine is a tiny machine for this thing yet. It's growing. It's going to look like one of those racks there, but it's not there yet. I did it against the will of anyone there, so they kind of allowed me to use this thing, and then they was like, oh, okay, now it's nice, and we can actually use it. And then I just use a cloud node, a cloud virtual machine for the web front end of this thing. That's it. A high cluster is a tiny machine. It has 16 GPUs, which are gaming GPUs. That's actually nice because the speed of inference of a gaming GPU and a 800 GPU is basically the same. It's just less memory, and it costs a fraction of it. Yeah, so I'm very happy that we are using this for inference instead of using the expensive GPUs that we can use for training. I use GlusterFS as the parallel file system. So it's a little cluster that I created as a copy of the supercomputers, and it's my EasyBuild testing bed. We have our own repo of EasyBuild in Jülich, which is for the supercomputers, and this is the one that I use for vanilla repo of EasyBuild. And before I send any pull requests, I test it here with the versions that we are using on the vanilla repo of EasyBuild. It's an old Ubuntu running there, and it's not going to change anytime soon if I can. And yeah, so before I was trying to keep everything on EasyBuild, and I realized that is absolutely impossible because those new versions of libraries, they bring whatever, the new NumPy that pip tries to take by itself. And then it takes a new Numba, that takes a new Clang, that takes a new PyTorch, whatever. Yeah, so I have a base stuff that kind of stops on Python. On top of that, PyPy with UV solves itself. As I said before a couple of times, it's impossible to keep this thing organized in a way that it's very chaotic, to be honest. I create a virtual environment for one model, see if it runs there, and then I go with that, because otherwise it's yeah, I like UV a lot, this replacement for the VM and for pip install. It's very nice. I recommend it and cannot recommend enough. It's super nice. Well, the website, you saw the link before. If not, is this thing. You can connect to it with, if you have EduROM, EduGain, whatever works, Gmail, or a GitHub account. So basically, it's open for everyone. It just has this authentication to keep from having too anarchic. Yeah, yeah. Play around with it if you're more than welcome to. The API. So it works like this. It's very simple, actually, how to get a token on this thing. You go to a GitLab. In this case, has to be our GitLab. So, but again, this GitLab is also open with any EduROM or Gmail or GitHub account. So you just come to it, comes to an access token with the API scope, create a token, and yeah, and that's it. Yeah, so you copy this thing. You can use Blablador programmatically. Yeah. So for example, I can actually open it here. So it uses Fast API. I don't know if you know this thing. So this exposes the API of itself as a website. So like here I can do an authentication with this token I created, and I can just run whatever here. Yes, if I try, there's a tryout somewhere. Yeah. So this is sending a command to Blablador, and this is how you get programmatically reply on the thing. You can just I can give the slides later if you you just copy this thing and you can play around with it. Yeah, so this is a little demo of it. So for example, yeah, you can just call with curl because it's a web request. Yeah, it's a stateless thing. Another thing that I did was to talk with these people of continue. So continue is this expression, this extension for VS Code. I have it here. So for example, oh, these are the slides itself. If I take continue is this one here. If I take something from here, just select this text. I have it already configured on my machine and say, what is this? Yeah, and okay. So yeah, okay, so write me a CFD code in C. I don't know. Yeah, so oh, that's really not a CFD code, but I said C is computational fluid dynamics.
Done for the context. Or...
Yeah, do it in C++. I don't know. It's not collaborating with me. Anyway, let me try with. Okay, so
that's the size of the model you're changing, or?
So I'm changing when I change here. I have them as aliases. So I have one model that runs on 8 GPUs, so I call it large. I have one model that runs on 1 GPU that I call fast. I have one model that runs on 4 GPUs, but it's a star coder. It's called star coder. It's made for code. That one that did the printf. So that I called code. Yeah. So that's it. So now it's the. Well, this is blah blah blah. Yeah, it's not answering me what I need, but yeah. Yes, you should. Okay. Ah, okay. Yeah, it's better than the previous one. Again, don't trust this as code. Yeah. Well, I will not get that far into this demo. But yeah, so the idea is that it's very easy to integrate it into any kind of programmatically thing. Yeah, you just point it to my server and that's it. Yeah, so here was just to show. Here's how to configure the thing. It doesn't matter. This is if you want to have a look at the slides. And people are doing a lot of stuff with it, as I said before. This was one talk by Peter Steinbach that he was very happy with it, and then he was showing how he uses it. This was another guy called Dimitri that gave a talk about Blablador, that he did some physics-based things there. This previous one about cosmology that I said, the guy also gave a talk on that, and it's on. Yes.
That model should be renamed.
Cosmosagigan.
Yes, true. So it was actually interesting that someone did not know that this was an API compatible with OpenAI and created reverse engineered bindings for it. And then I was like, yeah, okay, but why didn't you just use the OpenAI? And oh, I did not know that it was there. Okay. Geomar is the Geological Institute of Oceanographic Research of Germany or something like this. They created a chatbot on their website with this thing. So they put their data on top of it so you can talk about their stuff. Yeah, it's called TLDR. So there are people using it. So I'm very happy with this. Right now I have around 300 single users every day on the web interface and much more on the API. So it's very full. UDAT is something from the European Union is a service for cloud stuff. And they integrated Blablador on it. Like they have a little dog button here, and this is part of this open cloud, and you can talk to Blablador over the UDAT services as well. Yeah, there is there is one institute about Stratosphere in Jülich that is using this on their cloud. Someone created a Jupyter extension that creates plots with creates code, yeah, and on directly on Jupyter. So there are other places using, yeah. The German Space Agency is using it. Some company called Projekt Träger, the Interpol is using because of the privacy stuff. Yeah, at some point, every now and then I get some weird emails like, "Oh, we are using it. It's very nice. We love it." And yeah, so the Ministry of Agriculture, I don't know how they find those things, but yeah, I'm very happy with that. And to what there is to do, there's a lot of stuff to do actually. One of the things that I don't do it yet is running models multi-node. First because I didn't write code, and then when I wrote code, I realized that it's so slow that it's not worth it. But until I managed to convince my boss to give me bigger GPUs for this thing, I will probably play around with this thing again. The problem is memory, yeah? So if you have one of those models like 400 billion parameters, it doesn't fit in 8 gaming GPUs. There's no way I can do that. So another thing is that you can actually run your own inference server and point it to us. This is closed for now, basically to keep the firewall guy happy. Basically because no one asked so far. One of the inference codes is called SGLang, which is a very fast one, but it only runs in 1 GPU. This is something that I need to fix. I want to add multimodality, which is basically not just text, but to talk to images and generate images, like ChatGPT does now. Another thing is called RAG. RAG is retrieval augmented generation, which is basically to create a database of your own documents. And you can do this by hand. Right now, we have documentation for that, and point to a large language model. This is the way. This is the most efficient way to have to be able to talk to your own text or documents or whatever. What I want to do is to do this directly on the browser. I started code for that, so it looks like you are uploading a file, but it's actually doing the work on the WebAssembly on the browser, and this would just send the relevant parts to Blablador and talk back, and also OCR on the browser. Maybe an arena to compare models, but I didn't need I don't have enough models running from our own yet to compare like this. I have code to train large language models, but no one uses. Everybody uses their own code. Too bad, but yeah. And that's it actually. Yeah, I don't know if I'm on time. I hope so.
The time that was planned for yours is that's pretty much on time. We're half an hour behind schedule, but that's not your fault. All right.
Thank you. Yeah, so that's it. If you have any questions.
Yeah.
No dogs were hurt making this.
Can we get the code for this if we need to run it ourselves for some reason?
You can.
Because I think
it's on my GitHub.
Yeah, because I think we have an excellent case for this.
Yeah, sure.
Is it user support tickets?
GitHub.
There's lots of things you can think of that would be interesting to use a service like this for.
Yes, and so okay, so it's this.
So you mentioned it's overloaded now. Does that just mean it's slower than you want it to be?
No, it's quite full. Every now and then you might get an error saying that the system cannot handle.
Okay.
Especially in the code model. Usually when I see that, it's someone doing benchmarking. Like someone sends a trillion requests and checking different replies and what happens and things like this. But other than that, because the answers take a couple seconds and it's queued, so they work pretty well. Yeah, so here's the source code of this thing. I can just give you directly. Any other question? Yeah.
Right, really cool.
Sure.
I think you mentioned at the beginning of the talk that some of these models take like half an hour to load.
Yes.
I'm trying to understand how that's possible, given the sizes of the GPU's memory and so where is the bottleneck?
First is that this machine that I have uses hard drives in a parallel file system. So you have a slow disk in a parallel file system that makes it slower. And actually, this loading this thing to the GPU, it's slow by itself. So if I would put this on a NVMe local directly, it would still take like 10 minutes. So this thing, it goes to the CPU, and then once it is on the CPU, it's pretty fast. It uses the PCI Express to load it directly to the GPU. Or even better if you have a more fancy GPU, but it's still pretty slow. It's Python code. I think that PyTorch could optimize that part, but it's not up to me.
Okay, thank you.
All right, any more questions? Yeah, I'm keen to see where this is going at least. There's a question in the back.
Thanks. Does it produce proper easy config files?
Say it again.
Does it produce proper easy configs?
Does it produce proper easy config?
Oh, we can try. Let's see. Let's take the bigger one. This one is like, can you write an easy config to install a pip library? I don't know. All right, too long waiting here. Let me reload this thing.
It's funny how people are always very friendly when talking to me now. You can just be very like, do this.
Yeah.
Nobody does.
Write me a easy config for
Amber.
Amber. Okay. Oh God. No.
Yeah.
No. No.
But I guess you can tweak it to do so, right?
Yes. If you can play around with the prompting of the thing and say, oh, you are very nice, blah. Actually, it improves the quality of the responses. There is a very weird part of Twitter that is dedicated to this improving prompts. Yeah. So this one didn't work.
No, but if you tell it first, like you're an EasyBuild expert.
Yes. Yeah.
Give it some context, essentially.
Yes.
This would be really awesome.
The format doesn't look right, but the contents actually doesn't look too different than what it should be.
Yeah.
So I'm surprised that it at least resembles something.
Yeah.
Like
So it's weird. Yeah. But yeah. Yeah, and usually it formats well. I don't know what happened to this one. Like, yeah. Let me try with the coder model. Write me an easy config for Amber. You are the EasyBuild expert. Take a deep breath.
Yeah,
If you get this right, I'll give you a dog cookie.
You should tell it that you're
Completely wrong. Yeah, no.
crash, did you?
It's
Yeah.
getting faster, or is it me? No,
Yeah.
yeah, the speed is changing. Yeah, I don't know.
So, okay. No,
Yes. Yeah. So
no
oh, let's
Terminator.
try the llama that I put it to run like half an hour ago.
No Terminators just yet. So we'll see. No, but this is
Oh,
this is already. Yeah.
no.
That's
Yeah.
that'd be an input for
Yeah. All right. Yeah,
Yeah.
we should wrap up here because we really need to go for lunch. I will be in trouble.
Okay.
No, thanks a lot. This looks very interesting. And it's maybe something we could integrate into EasyBuild as well. Since it has a Python API, we could let EasyBuild talk to Blablador and
Yes.
like explain me the C++ compiler error, for
Yes.
example. Yeah. The risk.
Take the 360 megabyte PyTorch
Log file and
and find me the error there.
Tell me how to fix the broken test.
Oh, actually, well,
Yeah,
it's
this
not
is-
that bad. Yeah.
This is pretty good, actually. Yeah.
Yeah. What is GCC Fortran? Well,
Yeah, let's check some. It's getting some stuff. Yeah.
yeah.
It knows about the new names already, like build options. Yeah. Okay. Good.
Okay, thank you.
Let's wrap it up here. So we'll go out for lunch. Yeah. Let's wrap up the thing first. Thanks a lot, Alexander.
Sure.